So you have seen what this software is capable of, what the manifold interface approach is capable of, both for multi-channel amplitude panning and for other extended functionality that is now possible through the new implementations in Maximus P and Pure Data. I have several objects available. There's an audio rate panner, MIAP tilde, a control rate version of the panner that just sends out control rate messages with channel and speaker gain, an interlaced list of channel speaker gain pairs. There's a UI object, miap.map, that shows the maps and lets you interact with them. And then there's a utility external that translates, converts Meyer's proprietary project format, which contains maps in their software, into a human-readable JSON MIAP native file format that is used in the Max and PD objects. So quickly go through some details here of each of the objects. And next steps, the miap.map, the GUI object, is not implemented in Pure Data yet, so I'd like to do that. Map authoring, right now I have exposed a scripting language, a message language in Max and PD that lets you generate maps through messages. So I'm thinking that some interesting Max or PD programmer is going to algorithmically create maps and morph maps on the fly, and that's possible through the scripting language. The more intuitive approach is a GUI-based, mouse-based way of designing maps, and that's how I tend to design them. For that, right now, you should use MeyerSound's QStation software, the space map feature within that. I have information on my website about a link to that software. In the future, hopefully in the near future, I'll implement GUI-based map authoring inside this object. But for now, you should author that if you want a GUI approach in Meyer's software, and then use the utility miap.meyer object to convert the Meyer files into JSON files. I'd also like to explore expansions of the algorithm to go beyond triangular sets, especially at the boundaries of nodes. Fading out for silent nodes could benefit from sets that are more than 3 sides for smoothness. So I'm interested in Christian Bohr's edge fading amplitude panning algorithm that was also presented at AES this year. And I'm possibly interested in exploring the expansion of barycentric panning to 3 dimensions. Barycentric coordinates can describe the position of a point in a tetrahedron instead of just a triangle. That does complicate the interface, but I'm interested in the implications of a 3-dimensional abstracted mapped space to control a real space. So that may be something that I'll look into in the future. Thank you. The software is free. There's a link to the software right there. I have all of the examples that I showed are up on the website, included in the download package. I have videos of each of the examples separated on the website. I'd like to give a special thanks to Steve Ellison, Jeremy Freisner, and Richard Bugg, and everyone at MeyerSound Labs for both for creating the tool and developing the tool over the past few decades, but also for their generous assistance in this translation process. Thank you.